Okay, good evening. This is Professor David J. De Los Reyes. Okay, my topic for tonight will be trigonometry, and this will now be lesson number 13. Long video format, okay? Trigonometry. So for those of you who are in high school or going to college, this is for you guys. This is trigonometry lesson number 13. Okay, we are finishing a syllabus on trigonometry, and we are now on lesson number 13. Okay, let's proceed. Subject matter for tonight, trigonometry, lesson number 13. We are running smooth. And the title of the topic for tonight, okay, we are gradually going up on the what you call this stair of a trigonometry. The title for tonight will be Angle of Elevation and Angle of Depression. The last time around, I discussed the solution of a right triangle. Okay, there are 5 possible cases. Okay, and the other discussion next to that will be the so-called bearing of a line or a point, because there are some problems in trigonometry in which we encounter bearing and we encounter angle of elevation or angle of depression. Okay, so for tonight I will be discussing angle of elevation and angle of depression, because these words are actually incorporated in some verbal problems. So without knowing angle of elevation or depression, or you don't know how to plot a bearing of a point or a line, okay, there's a problem with the so-called solution of the problem. Okay, let's proceed. My purpose here in discussing the concept of angle of elevation and depression is that actually, at least we know how to plot angle of elevation and depression. So this is angle of elevation slash depression. Okay. For the angle of elevation, it is the angle measured upwards with reference to the horizontal. That's angle of elevation. An example of this, just to understand the definition of angle of elevation. If we are given a building here, and we are given we had an observer at point A. Okay. If we got a transit and we could direct this transit to the top of the building at point B. Okay, we are having a transit. We project it to the tip of the building, or the right at the corner of the building at point B. What we will be getting from the transit with respect to the horizontal is actually alpha. Okay? We call this alpha angle of elevation. So angle of elevation meaning the observer should be below the point that is being observed. Okay, this for it to be angle of elevation, this observer point should be lower than the point being observed. So the angle that we will be getting on the transit will be alpha, and we call alpha to be angle of elevation. Okay. For the so-called angle of depression, it will be the reverse. Right? The angle of depression will be something like this. We got a person maybe here and still got a transit to observe this point A here. Okay? So if he will project that transit going down, okay, hitting this point A here, what he will be getting from that transit reading will be beta. This is beta. Okay? And this angle beta is termed to as angle of depression. Okay? Or that's the difference between angle of elevation and angle of depression. For it to be called an angle of elevation, the observation point should be lower than the point being observed. And for the angle to be taken as a reading, the observation point should be higher than the point being observed. For it to be called angle beta, and we call it angle of depression. Okay, you got it? Right? So considering point A, if we project our transit over here and we will try to hit this point B here, the angle that will be taken from our reading will be angle alpha, and that angle alpha is actually equal angle of elevation. If we try to reverse it, the observer will be at the top of the building and he will try to observe point A on the ground. Okay? The reading that he will be having on the transit will be angle beta, and that angle beta is the so-called angle of depression. Okay? This is a horizontal line, this dotted line here. So actually this angle beta is actually measured with respect to the horizontal going down. For the angle of elevation, it is measured with reference to the horizontal ground going up. Okay? That's why it is angle of elevation. So angle of depression, this is going down. Angle of elevation, this is going up with respect to the horizontal. This is horizontal, still horizontal. So if the observer is at point B, what he will be taking as a reading will be angle beta, and that angle beta is termed to as angle of depression. Actually, angle of elevation is the same as angle of depression. The only difference is that for the angle of elevation, the observer is at the ground, and for the angle of depression, the observer is actually on top, for it to be called angle of depression. Okay, at least we now know what is angle of elevation and what is angle of depression. Okay, I will try to give you an example problem on the application of still right triangle, okay, in conjunction with angle of elevation or depression maybe. So the concentration of the subject matter will be like, because from the previous discussion, it will be solution of right triangles, right? So we will be having an example problem in which the solution will be by using the right triangle concepts plus our knowledge of the so-called angle of elevation and depression. Okay, I will try to read this one. I will try to read a given example problem. Am I still on camera? Right. From the top of a lighthouse, 148.7 feet above sea level, a boat is observed under an angle of depression of 18.11 degrees. How far is the boat from the observer? Okay, upon reading the verbal problem, at least you could visualize now what will be the required figure. So it seems we are given a lighthouse here. We assume that the lighthouse is erected perpendicular with respect to the ground. So this is a horizontal line. This is the lighthouse. We assume that the lighthouse is perfectly erected and it's not tilting. Okay, so this is the lighthouse. And this should be the shoreline, the water line. And this is the water level. And from the water level, an observer from the lighthouse, okay, maybe he does have a what they call this transit and how to determine this angle of depression. He observed that the boat has an angle of depression of 18.11 degrees. Okay, the angle of depression. So we will be applying our knowledge on the concept of angle of depression from the previous discussion. The observer is actually on top, right? So the angle that he will be taking on the transit will be angle of depression. It's not elevation because he's on top. He observed that angle of depression of this boat is 18.11 degrees. We assume that the water line is horizontal, okay? And this line here is parallel to the water line, okay? Parallel, right? So if we try to plot the angle of depression of this boat, it should be with reference to the horizontal line. This horizontal line is parallel to the water line, right? So this is 18.11 degrees, okay? And the height of the lighthouse, excuse me, is 148.7 feet. The problem is asking how far is the boat from the observer. If this is the observer, this is the boat, the distance of the observer from the boat is actually this portion here. We call this S. This one. From this point here up to here. That's the distance of the observer from the boat. Okay? So if this is a horizontal line, the water line is horizontal, the lighthouse is vertical, of course the angle here should be a right angle. So if we try to bring out this right triangle, it will be this. This is the height of the lighthouse. This is the observer. And this is the boat. Okay, as per the verbal problem, the angle of depression of this boat is 18.11 degrees. So with respect to the horizontal, this angle here is 18.11 degrees. Okay, and if this is horizontal line and this is a horizontal line, this is 18.11 degrees. So if this is 18.11 degrees, this should also be 18.11 degrees. They are congruent, right? They are congruent. This line here extends, intersecting the horizontal line here, and intersecting the horizontal line here. So if this angle is 18.11, this should also be 18.11. Okay? So we now know how many parts we now know on the resulting right triangle involving the lighthouse and the boat. We are given the height of the lighthouse, it's 114.7 feet. We assume it's vertical. This is the water line. We assume it's horizontal, so the angle here is 90 degrees. So from my concepts, this is actually angle C, which is equal to 90 degrees. Okay, as always, the angle C in the right triangle is 90 degrees. So what is given is this side here, and this angle here, and we are to look for S. Okay? We are given two values on the right triangle. Okay, we could erase this one now. So it will look nice. Okay? So we are now given two parts of the right triangle involving the lighthouse and the water line, including the boat. It's this side here, plus this angle here. And the one we are looking for here is S. Right? So we are given an opposite side, considering 18.11 degrees. And we are looking for the hypotenuse. So to solve for the hypotenuse S is actually the hypotenuse, right? Think of the relation, okay, involving the opposite side and the hypotenuse. And from the definition of the 6 functions under trigonometry, it should be sine. Because the ratio of opposite side over hypotenuse is actually sine function. Okay, don't forget that one. Considering this angle here, this is opposite side, this is adjacent side, okay, and this is hypotenuse. Okay, I will try to erase this one, so it will not bother us. Opposite side, considering 18.11 degrees, and this is hypotenuse. And from the definition of the 6 trigonometric functions, it falls under the sine definition. That is, the sine of this angle here should be its opposite side over its hypotenuse. So sine of 18.11 degrees will be 148.7, the height of the lighthouse, over the hypotenuse is actually S, the unknown distance of the observer from the boat. So this is over S, right? So we are now given this equation here. Solving for S, this is over 1, right? 1 times 148.7 will be 148.7. S times sine of 11.11 degrees will be the product. So if we try to compute for S, so we'll take this sine here over here, right? And this should be 148.7 over 0.3108. Okay? At least you've got no problem particularly simplifying this one. We are solving for S, so we multiply both sides by S over sine of 18.11 degrees. It's just something like that. So the left hand side multiplied by this one here cancel with this, it will be S now on the left hand side. And for the right hand side, 148.7 over S times S over sine of 18.11 degrees. This S here cancel with this. So what will remain on the right will be 148.7 and the sine of 18.11 degrees. As simple as that one. Okay, that's algebra. So what comes out is 478.37. So the distance of the boat from the observer, if the angle of depression observed is 18.11 degrees, it's 478.37. Okay guys, that's a practical application. Okay, so it will not be boring. We are only solving problem, particularly these triangles who got a dimension, but we will relate a right triangle to a real life problem like this one. Okay, we are not only solving a right triangle, we relate this right triangle in real life problems. Okay, good evening from Los Angeles. Professor David J. De Los Reyes.